Good morning, class. Today, we're going to be talking about quite a few things, and the primary thing is studying angular velocity. So there's a lot that goes along with this, and I'll just start here. That's the painting brush brass. So let me just go ahead and undo that. So, let me make sure I'm okay. There we go. This is, I don't like rotational. I was going to say rotational, but angular velocity. And angular velocity is going to speak to quite a few things. So this is our goal, okay? And there'll be a few concepts that we need to discuss. So if we look at angular velocity, basically this is a rate, okay? A rate of change. And so you're thinking about the angles in terms of how they're changing with respect to time, okay? So we'll also need to know about velocity. And let me just be clear on this one. It's going to be tangential velocity, okay? So that's another thing. Now this is basically, believe it, well, tangential velocity is the velocity that's going to occur as though you're just changing speeds. Well, not changing speed, but you have a certain speed in a certain direction as you're running. It's similar to that. And then we're going to have the distance between 2 points. And when I say distance between 2 points, let me just cut to the chase and call it the radius. All right. We're going to be using Pythagorean's theorem. To calculate, okay, both the tangential and radius, so as to calculate the angular velocity. Okay, so we have that, and what else? I think I'll stop right there. There are quite a few things that we can pull out of this, but I think I'll stop right there. Okay, so here we go. Angular velocity is coming out of this idea. Let's just say we have a horizontal. Well, we're going to have a horizontal axis. Let's just call it the X. And we'll also have a vertical axis. Let's call that the Y for simplicity. Let's say that we have a point out here. That point came from this location. We went around like so. So that means we have some angle that's measured from the positive x-axis. So the angle at the positive x-axis is 0 degrees. In this particular case, we're going to use radians. So 0 radians, all right? And then you have some final angle. Okay, and that's going to be just some other location. So basically from this we are going to get some delta theta, which is just theta final minus theta initial. Now since the initial angle is 0, and it probably will be for each one of these this consideration, it doesn't have to be, but I'm giving you insight into it. That means that delta theta is just going to end up being theta final. So instead of writing all of this, we just say theta. That's why you'll see theta there, right here, okay? So the tangential velocity is going to look like this. It's going to be tangent to what would be considered a circle. And then we'll have a radius here, okay? So a radius. The radius is the distance from the center of the circle to this location. Let me get a different color pen. It's going to be from this location to this location. Okay? So that's going to be our radius. All right? So what are we going to do? Well, The thing that we know will be the value for x and y. So if we know x and y, x happens to be, oh, I went too far. X happens to be this value, and you can see that it's moving in the positive direction. And y happens to be this value, okay? So it's moving in the positive direction as well. And that's also indicated by the non-negative signs. So both of these will be positive in this quadrant. This is called quadrant 1. Okay, I just want to, let me get rid of those positive and negative, and I'll just put quadrant 1 back there. Okay. We'll also have velocity done that way. So we'll have velocity in the x direction, and we'll have velocity in the y direction. Okay? So from that, we can develop a little bit of theory here from Pythagorean's theorem, and the first portion will be using the idea of c squared is equal to a squared plus b squared. Basically, this is saying that the sum of, well, think that I probably should do something like this. Here we go. So if I draw a square here, it might be too. I draw a square right here. Then I draw another square right here. Then I draw another square right here. Okay, and we call this square, we say that the sides are A, and on this one we say that the sides are B, and on this one we say that the sides are C. So when we compare the areas, we can have c squared, because length times width is equal to c squared, and then we have a squared and b squared. So these are the areas of these squares. And so basically what Pythagorean's theorem is saying c squared is equal to a squared plus b squared. Now what does that mean? That's saying that the sum of the largest area is equal to the sum of the two smaller areas. Okay? So even though we're talking about that from that perspective, what we really want to draw out of this is this equation here. With this equation, we can write something like c is equal to a squared plus b squared, and we could take the square root. All right? So we could also say that in general, c is just going to be S Q R T P O W E R power of power x to the second plus power of y to the second. Okay, in general. And now I wrote that formula because this is the formula that we're going to use in Microsoft Excel. Again and again and again when it comes to utilizing Pythagorean's theorem. So go ahead and memorize it if you can. So if we're going to use that with this triangle up here, we can use it to calculate r for the first triangle, or for the distance triangle, and we can use it to calculate VT for the tangential velocity triangle. So I can just choose a different color here, and let's go ahead and calculate r. So basically we're saying that r squared is equal to x squared plus y squared. So that means that r can be found fairly easily. So this is going to be our distance for r. That's why, and we're going to use that same formula down. At the lower on the lower end. Vt squared is equal to Vx squared plus Vy squared. Again, in order for us to find the tangential velocity, we're going to basically have this vx squared plus vy squared. Okay? So why do we do all of these calculations? Well, what is it leading to? It's leading to us understanding our understanding angular velocity. So instead of me deriving it, I'm just going to tell you that angular velocity is omega. Let me pick a different color. Angular velocity is omega, and it equals to the change in the tangential velocity over the change in r. Okay? And so I'm going to, yeah, I'll leave it like that. Okay? So from here, we can just write omega equals to the square root of the velocity in the x direction squared plus the velocity in the y direction squared divided by the position in the x direction plus the position in the y direction, and we'll have our angular velocity. This is what we're pursuing, all right? So this is primarily the theory. We're going to apply descriptive statistics to this, and then we're going to apply inferential statistics, okay? That is the end of this portion of the video. In the next video, I would like to start experimenting or extracting data from videos.